Hi, I'm Mudinda and I'm here to help you understand maths better for free. Now, matriculants, in today's video, we're going to be talking about sketching cubic graphs. This is actually our 9th video in our grade 12 calculus video series, so make sure that you've watched the first 8 videos. We're going to be discussing the shape of the graph, inflection points or points of inflection, stationary points, as well as how to find the x and y intercept of a cubic graph. Let's jump right into it. Cubic graphs are in the form f of x is equal to ax cubed plus bx squared plus cx plus d, which is usually quite daunting at the start for most learners because for most of your high school maths career, you only look at quadratic functions, never really cubic ones. So it's the first time that you do them, but they're actually not that bad. Now, how does a cubic graph look? Well, the shape of it depends heavily on whether this a here is positive or negative. If a is positive, then the shape looks something like this. But if a is negative, the shape would look something like that. Now, I know these could be looking like just some weird snake shapes that aren't so different, so let's unpack that a little bit. A cubic graph is basically just two parabolas stuck together. For example, if you took a smiling parabola like that, which we actually now call a concave up shape, and you stuck it together with a frowning parabola graph, which we now call a concave down graph. If you stick them together just by their edges there, then you'd get a diagram that looks something like that, and that's what a cubic graph looks like. Like I said, if a is greater than 0, the graph looks something like this, meaning it starts with the frowning half, the concave down half, and then comes the smiling half, the concave up half. So when a is positive, the graph starts by being concave down and then concave up. But when a is negative, the graph starts by being concave up and then concave down. By the way, matriculants, all these notes are attached in the link that's in the description box below if you want to download the notes to this video. Now, something that we haven't looked at is this little point here. The point where if a is positive, it would be the point where the graph stops being concave down and starts being concave up. We call that the inflection point or the point of inflection. Of course, if a is less than 0, that would be the point where the graph stops being concave up and starts being concave down. It's a very important point, the inflection point. How do we find the inflection point of a cubic graph? Well, you have to note the following, that at the inflection point, the second derivative is equal to 0. So at the inflection point, the point where concavity changes, in other words, where the graph stops being concave down and starts being concave up, or the other way around, where it stops being concave up and starts being concave down, that's the point of inflection. It's the point where concavity changes. Its concavity changes there. And at that point of inflection, the second derivative is equal to 0. Now, you might be confused as to what a second derivative is because we haven't ever spoken about a second derivative, just a first derivative. But to find the second derivative, you're simply just going to derive twice. Okay, so if you wanted to find the point of inflection, first you'd find the second derivative by deriving twice, and then you would set that second derivative equal to 0 and solve for x. That will give you the x value of the point of inflection, which you can substitute back into the original f of x equation to get the y value of the point of inflection. Let's look at some examples together. So let's look at an example here, matriculants. This one says determine the point of inflection if you're given that f of x is x cubed plus x squared minus 17x plus 15. That's an equation of a cubic graph. Like I said, we're going to find the second derivative by deriving twice. Let's derive what we have now, that is now 3x squared plus 2x minus 17. If you struggle with deriving, we do have a video out on that, so make sure you give it a watch. Then let's find the second derivative by just deriving one more time. F double prime of x, this will be 6x plus 2. That is the second derivative. Now we know that at the point of inflection, the second derivative is equal to 0. So we equate 6x plus 2 to 0. And then we try to solve for x. We'll get that negative 2 is equal to 6x. And if I divide both sides by 6, I'd get that therefore x is negative 1 over 3. And now you have to find the y value of the point of inflection. This is the x value of the point of inflection. In order for us to find the y value, we're going to plug in the x value of negative 1 over 3 here in place of x. Because remember, the parent equation itself, if we give it an x value, it spits out a corresponding, if we give it an x value, it spits out a corresponding y value. Okay, so we need to find f of negative 1 over 3. And I'm going to need your help there with your calculator. If you put negative 1 over 3 cubed plus negative 1 over 3 squared minus 17 into negative 1 over 3 plus 15. Let me know what you get. Just put that in your calculator. I'll put it in mine. Negative 1 over 3 cubed plus negative 1 over 3 squared minus 17 into negative 1 over 3 plus 15. So this is giving me 560 over 27, which is something like 20,74. Meaning, therefore, that the point of inflection is negative 1 over 3 and 20,74. Go ahead and try to find the point of inflection. Here you're given x cubed minus 2x squared minus 5x plus 6. Give it a try before just watching us do it in the video. And so in this one here, to find the point of inflection, would derive the first time to get the first derivative, which is 3x squared minus 4x minus 5. Then we'd find the second derivative, which would be 6x minus 4. Then we'd set that derivative equal to 0 in order for us to find the x value of the point of inflection. We know that the point of inflection is where the second derivative is 0. Moving forward to this side, I have 4 is equal to 6x, and if I divide both sides by 6, I'll get therefore that x is equal to 2 over 3. Then I need to find f of 2 over 3. You can go ahead and pause the video, put that in your calculator, but you should get something like 2,07. And so the point of inflection is 2 over 3 and 2,07. Great, so that's how matriculants you find the point of inflection. Now, matriculants, another feature of, we've been talking now about inflection points, and like I said, it's the point where the graph changes its concavity. Another feature of cubic graphs is they also have stationary points or turning points here and there. They have 2 turning points, unlike a parabola, which would have only 1 turning point. We've learned about stationary points, though. We've learned that at the stationary point, the gradient is 0, or the first derivative is 0. So if you want to find the stationary point of a cubic graph, you're going to set the first derivative equal to 0. Then you're going to solve for x. That's going to give you the x value of the stationary point. You plug that x value back into the original equation to find the y value of the stationary point. Same concept or same process as when we were finding the inflection point, but we won't derive twice, we'll derive just once. Let's look at some examples here. I have here g of x. If I wanted to find its stationary point, I'd start by finding g prime of x, which is 3x squared minus 2x minus 12. Then I would equate that to 0. Because when I do that, I'm finding the stationary point, because it is at the stationary point where the first derivative is equal to 0. Now, to solve for this, I can't factorize that. I don't know about you, but I'm just going to use the quadratic formula, which says x would be negative the value of b plus or minus the square root of b squared minus 4 into a times c, all divided by 2 times a. Which means in my case, x would be negative into negative 2 plus the square root of negative 2 squared minus 4 into 3 into negative 12, all divided by 2 times 3. Now, you can go ahead and press your calculator. I don't want to waste too much time in this video. So the x values you should get are 2,36 or negative 1,69. Now, you just found the x values of the stationary points. because it is only at the stationary points where the first derivative is equal to 0. To find the y value of the stationary points, you can go ahead and plug the x values into this parent equation. Pause the video, give that a try. You should get, on this one, a y value of negative 8,75. On this one, a y value of 24,60. Meaning that our stationary points are at 2,36 is to negative 8,75, and at negative 1,69 is to 24,60. Those are the stationary points of our cubic graph there. Now, just for practice, I do encourage that you go ahead and try this one here. Okay, I'm about to write down what the answers should be, but make sure that you give it a try. The first stationary point would be negative 4,07 and negative 7,04. The second stationary point would be 0,73 and 48,52. Okay, awesome. We are now ready to sketch a cubic graph. So I just want to mention that finding the x-intercepts of a cubic graph can be tricky. But that's only because you're required to factorize a cubic polynomial when you do that. And we actually already have a video out on how to factorize cubic polynomials. Before you backtrack to go watch it, you can try see if you understand the process we'll follow first. But if you do struggle with factorizing cubic polynomials, I suggest you watch that video. Let's get sketching. Imagine we were asked to sketch this graph, f of x. And they said to ensure we plot stationary points, intercepts with the axes, as well as the inflection point. Let's get into it. Let's start with our stationary points. Since we know that f of x is equal to x cubed minus 4x squared plus x plus 6, we're going to derive that to get the first derivative of 3x squared minus 8x plus 1. We're going to equate that derivative to 0 because we know that at the stationary point, the first derivative is equal to 0. We can't factorize this, so to solve for x, we're going to employ the quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2 times a, which in our case would be negative into negative 8 plus the square root of negative 8 squared minus 4 times 3 times 1, all divided by 2 times 3. Now in my calculator, when you use the plus and the minus there, you're going to get an x value of 0,13 or an x value of 2,54. Okay, now we need to take that and find the y value when x is 0,13 by equating or by substituting an x of 0,13 there. Okay, the y value when x is 0,13, that's taking 0,13 cubed minus 4 times 0,13 plus 0,13 plus 6. Now that gives me a y value of 6,06. Then we find the y value when x is 2,54. The y value when x is 2,54 is 2,54 cubed minus 4 into 2,54 squared, sorry, that should have a squared there, plus 2,54 plus 6. Now that gives me a y value of negative 0,88, meaning we have a stationary point at 0,13 is to 6,06 and another one at 2,54 is to negative 0,88. These are our two stationary points. I've just done some calculator work there, but it's the exact same thing we were doing previously when we were finding the stationary points. Now let's go ahead and find the intercepts with the axes. Now the easy one is the y-intercept. We know that to find the y-intercept, we simply let x be 0, right? Meaning, in the equation, y is equal to x cubed minus 4x squared plus x plus 6, we're going to make x there 0. 0 cubed minus 4 times 0 squared plus 0 plus 6. You're just going to end up with the y value of 6. So the y-intercept is an x value of 0 and a y value of 6. Now, let's find the x-intercept. Now, in order for us to find the x-intercept, we know that f of x is x cubed minus 4x squared plus x plus 6. We're going to equate that to 0. So 0 is equal to x cubed minus 4x squared plus x plus 6. Now we need to factorize this guy over there. In order to factorize this well, we first need to find the x value that makes this expression 0, or an x value that makes this expression 0. And like we did in the previous video, I really recommend you watch that previous video where we were looking at how to factorize a cubic polynomial. But we said you'll just try numbers like -1, 0, 1, maybe even -2 and 2. You'll just plug in those as random x values until you find the one that makes the expression 0. For example, here, if you put f of -1, you'd get -1 cubed minus 4 into -1 squared plus -1 plus 6, and that actually gives you 0. And so we know that therefore x plus 1 is a factor. Okay, I hope you remember this from the previous video. It's just a 9-minute video if you haven't watched. But because of this, we now know that instead of just having this statement as it is, we're going to say 0 is equal to x plus 1, then open another big bracket where we will put a trinomial. And remember, the point is, however we factorize this, if we were to simplify it, it should be able to bring us back here. And for that reason, I will put an x squared here, because then x times x squared will give me the x cubed back. I will also put a plus 6 here, because then when 1 multiplies 6, I'll get the plus 6 back. And like we said in the previous video, we will then focus in on getting this x squared term. And we said the x squared term comes from two operations. When 1 multiplies this term, you'd get x squared. Then we're going to want to put an x term here, and when this x multiplies that x term, we'll get another x term, and together they must give us that middle term of minus 4x squared. We've gone through this thoroughly, like I said in that previous video, so give it a watch if you haven't. But what number can I add to x squared to get minus 4x squared? This is 1x squared. I want to know what to add to it to get minus 4x squared. You'll agree with me that I must add minus 5x squared. Okay, so that's why we're going to put here minus 5x squared. So essentially now what we have is 0 is equal to x plus 1 into x squared minus 5x squared plus 6. And we're going to go ahead and factorize this guy here as well. So we have this x plus 1. Here I'll put x and x, minus 3 and minus 2 other factors. Therefore, x plus 1 is 0, x minus 3 is 0, x minus 2 is 0. Meaning, x is either minus 1, or it's 3, or it's 2. Meaning that our x-intercepts are minus 1 is to 0, 2 is to 0, and 3 is to 0. If all of this sounded like gibberish, make sure you go watch that 9-minute video. It's going to sound so easy after you watch that video. Okay, great. We now have found our stationary points and our intercepts with the axes. Now we will find our inflection point, but I actually just want us to now go ahead and sketch and see how this graph is going to look. So let's go ahead and sketch here. The orange points are our x-intercepts. We had minus 1 is to 0, we had 2 is to 0, and we had 3 is to 0. I've actually forgotten here our y-intercept, which we had found to be 0 and 6. So somewhere here at 6, the graph cuts the y-axis. And maybe let me just extend this a bit further to have 7 and 8 there. Then we have our stationary points at 0, 1, 3, and 6, 0, 6. 0, 1, 3 somewhere here, just between 0 and 1, and 6, 6 is somewhere over there, so that point is here. Okay. Then we have 2 comma 5 4 somewhere between 0 and 3 and negative 0 comma 8 8. So somewhere here we will have the other stationary point. Now we also know here a is greater than 0, so our graph will start by being concave down, then concave up. We're going to go ahead and just join these together in that fashion, okay? So we're going to go this way, turning point, back down like this, intercept, turning point. Okay, sorry about that. I don't know why it's automating that. Yeah, then this way. Okay, so this is the sketch you'll end up having. And very importantly, you'd want to show each of these points. 3 is to 0, 2 is to 0, minus 1 is to 0, 0 is to 6. And this one was 0 comma 1 3 is to 6 comma 0 6. And this one here was 2 comma 5 4 to negative 0 comma 8 8. And there you have it. You have your sketch, right? You're going to get all the marks. And let's just go quickly to my automated graph sketcher here and prove that that's indeed what that should look like. I'm going to put here x cubed. We have minus 4x squared. We have plus x, and then we have plus 6. So that's the equation that we were given. If you zoom into this picture here, you'll find there's 2 comma 5 4 negative 0 comma 8 8 as a turning point or a stationary point. There are the 3 different x-intercepts. There's 0 comma 1 3 and 6 comma 0 6, and there's the y-intercept at 0 to 6. So we know that we've actually sketched this quite correctly. Great.